Okay, I am doing the last video of the time series section of the textbook. I just want to make sure that I'm definitely recording, which I am. So this is 6E, looking at putting data into your CAS after you may or may not have deseasonalized it, and for, getting a equation. So this one here is an example of just putting in regular time series data into your CAS and putting in the type of graph XY line, and then you'll get a time series graph like this, and it will be all jagged like a normal time series graph, etc. So when you get up to 6E, this is where we start fitting a trend line, making predictions, and reseasonalizing if we need to. So if you're fitting a trend line using raw data, so you use the same steps to create a least squares regression line from chapter 4, and then you can use this equation to predict or forecast future values. Now, obviously, if you're forecasting or doing a prediction in the future, we don't have sales figures or whatever you're forecasting for. We don't have those figures. That's a prediction, so it is extrapolation, and we consider it unreliable. If you are fitting a trend line using smooth data, for example, deseasonalized data, you use the same steps to create the least squares regression line from chapter 4. This equation can be used to calculate deseasonalized predicted forecasted value. So to be meaningful, this deseasonalized value must then be reseasonalized. So that means you have to put in the seasonal effect back into it using the seasonal index for that particular part of the season. All right. So to get your actual figure, revisiting this equation again, you get your prediction from the deseasonalized figure, and then you times by the seasonal index. So again, it depends what sort of equation you have. So if you've got the actual data, the predictions you are making is an actual prediction. So it's with the seasonal effect in it. If you're using deseasonalized data, obviously you're going to get a deseasonalized prediction. So if they're asking you for a seasonal effect inside it, you're going to have to do a two-step process here to put the seasonal effect back into it. And again, future values, we're extrapolating. For example, if you have got what are we looking at here? So the number of the following table, which shows the number of government schools in Victoria over a period of 1981 to 92, and so fit a trend line and interpret the slope. So it depends. Just note the question. So if it's saying to change the values of the year to year number, so for example in this question, year number 1 means 1981. So this is year 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So they are the numbers that you're putting in for list 1 or your EV in your CAS. So if it doesn't specify, if this was a open question where you're just doing multiple steps, if you wanted to use the whole year number, you would get a different equation, different numbers to these, but you would be subbing in the actual year number to get your value. So just be very careful to see what the question is asking you to do. So if it is asking you for to change it into a year number where it's given you like a starting reference point, then please make sure that you're changing yours to that as well. Otherwise, you're not going to get the right answer. And if it doesn't specify, go nuts, do whatever you want, as long as what you're subbing is the same as what you put in your calculator. So this particular question is using the year number, so 1, 2, 3, 4, all the way down to 12, and the corresponding number of schools. So the steps here have just looked at the normal time series graph there, which is all jagged. If we want to have a look at the regression, least squares regression, it's the same steps. So calc, regression, linear, list 1, list 2, and we press OK. So for this one in this format, it would be number of schools is equal to, let's go, I'm going to go no decimal places. So let's just go for whole number, to the nearest whole number. And then we've got minus 13 times year number. All right, so that is my least squares regression equation. So interpreting the slope, which is b, so over the period of 1981 to 1992, the RV, which is number of schools, on average, why is that not coming up? Decreased by 13 schools per year. So that's just increasing, interpreting the slope, which you've done 1,000 times before. Right, so trend line forecasting using raw data. So how many government schools do we predict for Victoria in 2015 if the same decreasing trend continues? So 2015 is, so if we've got 1991, so we've got 1993, 94, 95, 96, 97, 98, 99, 2000, all the way down to 2015. So this would be 13, 14, 15, 16, 17, 18, 19, 20, 21, and then you would sub in the number for 2015. All right, so, and you would get a prediction using this equation. So that is how you do it that way. Now, I'll just show you quickly how it's different if you use actual years. It is still going to predict the same, but you can't flip-flop between year number and putting in the years. Show you what I mean. So I've put in the data. Now, as you can see, I've used the actual years, like 1991, 1981, 82, blah, 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 all the way up to 1992. So I'm going to do, it's going to look the same when I put this in. If we have a look at the graph. So it looks the same. Obviously, these numbers in here are now year numbers, not actual years, not year numbers. So instead of being 1, 2, blah, 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 I've got 1981 and 82 and blah, blah, blah. If I want the least squares regression equation, calc, regression, linear, same thing. List 1, list 2, fine. So as you can see, that is in the right format. As you can see, my numbers here are quite different, aren't they? So the y-intercept is very, very different because for the explanatory variable, I've put in the actual year rather than the year number, so the abbreviation of what the year is changed to. So I've used thousands of numbers rather than 1, 2, 3, 4. So obviously the A value is somewhat huge. However, if you have a look at the B value, it's very similar to what I had before. It is exactly the same. So when I was rounding that up, it's still decreasing by 13 schools. All right. So if I was to use this equation, if this was a short answer question in your exam and you were just asked to make a prediction and you could put this in however you wanted, you could do it with full years in your equation. It wouldn't make a difference as long as what you are subbing in is the same as what you've put in list 1. If you use year numbers 1, 2, 3, 4, 5, 6, you've got to work out what the corresponding number is for 2015. So you'd have to work out what that is. If you had done what I did and put in the actual year value, so 1991, 92, whatever, you would have to sub in 2015 into the equation. So totally up to you. If the question is asking you to change it into a certain year, like 1996 stands for 2, then you'll have to do that, especially if it's asking you to write an equation. So follow the instructions on the question always. All right. So what's that? 26933. Just going to write this down. So 26933 was A and B was negative 13. So if I was using number of schools equals, so 26933 minus 13, and it's the actual year. So to do this one here, I would go 26933 minus 13 times 2015. And that will predict roughly, because I've rounded here, the same as if you change 2015 into the corresponding number. You'll get about the same numbers, but just remember that I have rounded those, so that would be very close. Should I do that? 26933 before I... So 26933 minus 13 times, what was it, 2015? So it would be forecasted to be about 738. So 738 schools. All right, and then obviously 2015, we don't have data for 2015, so this would be extrapolation, and it would be an unreliable prediction because who knows what is happening to this data past 2013.